Okay, guys. Today we just want to talk about simplifying imaginary units with exponents. So if I wanted to say something like this, first we need to know our definition of what exactly the imaginary unit, the imaginary number is. Okay, and that is that the square root of -1 is equal to I. Okay. So first important thing we need to know is that the square root of -1 is I. Okay. What if I said, what is I squared? Well, that would be the square root of -1 squared. And one of the things we do know is that squares and square roots are inverse operations. So if I square this square and this square root undo each other, and that leaves us with just -1. So useful thing for us, and again, why the imaginary unit for a lot of us, unless you're going into electrical engineering, is just going to be a placeholder, is that sometimes if you have two imaginary units and you multiply them, you get a real answer. -1 is a real number. I squared is -1. So what we want to go through today is, first of all, this is that I squared is equal to -1. Okay? Again, if you know a little bit about fractional exponents, one of the ways you could do this, and again, this is not my students right now, but this is just kind of for future reference when someone else asks me about this. If I said this, if I said, hey, what's I squared, and I said that is the square root of -1 squared, don't forget that that's -1 to the 1/2 squared, right? Which is going to be 2. Okay, but I digress. Okay, so big thing takeaway so far: square root of -1 is I. The I squared is going to be -1. What if I said, what about I to the third power? Well, what is I to the third power? Isn't that really just I times I squared? It's a true story, isn't it? But I also know that I squared is -1. So what I can do is I can kind of break these down and say, hey, well, I times -1 is going to be -I. So I know we haven't really talked about that, but are there positive and negative imaginary numbers? Sure. Why wouldn't there be? Okay? What about I to the 4th power? Well, I to the 4th power is kind of going to be our magic bullet. It's going to be amazing. Okay, so this is what's going to help us out. I to the 4th power is actually I squared times I squared, right? I squared times I squared is really I, right? Or I to the 4th, right? I times I times I times I. Okay? But again, I squared, we said, was -1. And -1 times -1 is, bingo, +1. Okay? So that is good news for us, okay? Because now not only do we get a real number, we get a real positive number. Okay? So this is going to be our pattern. Okay? This pattern is just going to repeat again and again and again. Okay? So the big thing we want to do is we want to divide by 4. So just to show you, if I said, hey, what's I to the 5th? Well, I to the 5th is just I to the 4th times I to the 1st, which is 1 times I. I to the 6th, again, you're going to see this pattern repeat, should be -1. So again, whenever we can pull out an I to the 4th, it's very much going to help us. So if I said, hey, what's I to the 6th? Well, that's I to the 4th times I to the second. Well, I to the fourth was just 1. And I to the second was just -1. So 1 times -1 is -1. So if you see again, I, -1, I, -1. I to the seventh is again broken down. I to the fourth times I to the third. I to the fourth is 1. Okay, I to the third was -I. And again, I to the eighth is going to be I to the fourth times I to the fourth, which is 1 times 1, which is 1. So again, we see I, -1, -I, 1. I, negative, it's supposed to be an I, sorry. -1, -I, 1, right? So we just kind of have this pattern that goes on and on and on and on. And just to support your fact, we know that anything raised to the 0 power is 1, right? So if we continue this pattern, I to the 0 power is 1. So it does 1, -I, -1I, 1, and it would repeat going down and down and down. Okay? So again, let's go ahead and let's take a look at some examples and how you're going to find this. So what if I said I to the 16th? We know that 4 goes evenly into 16, right? This is I to the fourth times I to the fourth times, all right, times I to the fourth times I to the fourth, right? 4, 4, 4, 4, 16, right? Well, we know that that's 1 times 1 times 1 times 1. So it's 1. So the first thing you want to do, sorry, let's get my calculator. The first thing you want to do is if you have, why it keeps coming up with that? If you have any exponent that is divisible by 4. So if I said 16, I said, is that divisible by 4? You said yes. The answer is going to be 1. So in other words, if there's no remainder here, your answer is 1. Okay? So if I said I to the 60th power, I to the 60th power is 60 divided by 4, an integer. 60 divided by 4, right? Yes. No remainder, this is equal to 1. Okay? So again, this is what you're going to get when there's no remainder. Okay? So if there, oh, sorry, not this one. This one. I have the fourth. If there's no remainder, that's you. Okay? It's 1. Okay? If you have a remainder of 1, okay, so again, if I said 21, I to the 21. Well, 21 divided by 4. Okay, so we want to see if 4 goes in because I have the fourth. Well, 21 divided by 4, well, 4 goes into 21 5 times, and then I have a remainder of 1, right? So again, so what's it going to be if I have a remainder of 1? So I have a remainder of 1, it's going to be I. Okay? If I have a remainder of 2, and if I have a remainder of 3. Okay? And just to kind of put that in a better spot, you should really be up here with your exponents, right? No remainder, 1 is remainder, 2 is remainder, 3 is remainder, okay? So really all you need to do is divide your exponent by 4. That's it, okay? If you don't have a remainder, okay, your answer is 1. If you have a remainder of 1, it's I. If you have a remainder of 2, it's -I. If you have -1, if you have a remainder of 3, it's negative I. If you guys are not so good with remainders and you prefer to just put these numbers in your calculator, this will be an integer. When you do, so divide by 4, integer. For this one, if you divide by 4, it's going to be a remainder of 0.25, of 0.5, or 0.75. Okay? So what I really strongly suggest you do is, as you're doing these problems, you kind of keep this chart handy. Okay? So I'm going to bring up some problems and we'll take a look. Okay, so let's take a look at a few examples. Okay, so like I said, I would keep this little chart kind of handy. If you guys want, I'll see if I can post one on there for you. But it says I to the third power. Well, I to the third power we know is negative I. Okay, I to the second power we know is negative 1. I to the fourth power we know is 1 because that's our bread and butter. That's what we want, right? Good. I to the sixth power. Okay. Well, again, what's 6 divided by 4? 6 divided by 4 is 1.5. Okay. So since my number ends in 0.5, negative 1. Okay. I just anything raised to 0 power is 1. Answer. Done. Okay. I to the fifth. Okay. So again, I know we did that one, but hey. What's 5 divided by 4? Again, we're always dividing by 4 and seeing what the remainder is. I have a remainder of 0.25. 0.25 means that my answer should be I. I to the 88th. Okay, so what's 88 divided by 4? No remainder? No remainder, right? Boom. Your answer is going to be 1. Okay, 81. 81 divided by 4 is going to be a remainder of 0.25 I. 162. Again, they're just going to give you these ridiculous huge numbers. All you need to do is divide them by 4. Nothing crazy. Okay, what's your remainder? 0.5. Therefore, your answer is going to be negative 1. Okay. 769 divided by 4, pretty straightforward, ends in 0.25, it's going to be, I think you could just type in I.